Good afternoon or good morning, depending from which region you are watching us. Welcome at another ENS webinar. European Nuclear Society is preparing webinar time to time for participants from all over Europe and maybe far beyond. And today we are gathered here to have a webinar dedicated for long-term operation of nuclear power plants in Europe. My name is Ondřej Novak. I will be person guiding you through this webinar today. We have two guests that are going to speak. At the beginning, the LTO is in general very attractive topic for us to make nuclear power plants running for a longer time. And it's not just the economic motivation, but also the technology itself allows to explore such ideas as extending operation from 40 years to 80, which wouldn't be possible if the power plants wouldn't be strong enough or built well enough to handle such long duration of operation. And even though they need some support by economical changes or maintenance and upgrades, but still the technology is possible to allow such long operation, and for the decarbonization and effective utilization of nuclear power plants, it's an attractive topic. And therefore, a lot of companies which are operating nuclear power plants are exploring this topic. It's a very attractive topic. However, informations are sometimes not available in large scale because it's also a very sensitive topic. If you imagine on the stock market, if you say that the nuclear power plant will be operated for more 10 years more, the stock market would react to that and vice versa. So it's very often difficult to get some detailed information about the LTO plans of each company. Today we have two guests which are going to discuss this topic. First guest will be Robert Křiváněk, who is expert in LTO at UJB Řeš. He will give us some presentation which would give us general overview of the LTO and how these things works, what's the regulation around it, and etc. And then we will jump to second presentation by Andreas van Wiek, which will give us the explanation of practical example of one of the Belgium power plant, how they are handling the LTO there. So this is the plan for today's afternoon. We will have 20-minute presentation roughly, and then it will be time for your questions. So if you will have questions during the presentations, feel free to write them in the chat, and we will pick them up later once both presentations will be finished. So don't hesitate and ask questions already during the presentation, so you don't forget on the questions which were placed by you. So let me ask Robert Křiváněk to start the presentation.
Okay, so yes. Good afternoon. So my name is Robert Křiváněk, and I am currently with UJV Řeš in Czech Republic, and I will have a presentation on a global overview on the needs, aspects, and requirements for LTO beyond 60 years. So in my presentation, I will touch three topics. First one, current perspectives of LTO beyond 60 years. Then development of IEA safety standards and other publications. And finally, OECD NEA LTO beyond 60 years project. Objectives, report structure and content, and conclusions. So first, current perspectives of LTO beyond 60 years. Safe LTO of nuclear power plants has many challenges, but also many benefits. Major benefits of safe long-term operation comparing to other energy sources are economic. It is one of the most profitable options to produce low-carbon energy. Environmental. It is one of the most significant low-carbon energy sources in current energy mix. And energy security, important factor ensuring independence from external sources of energy like gas, oil, and coal. There are also additional advantages of safe long-term operation, which is employment. Continuous operation of nuclear power plants helps to maintain and stabilize highly qualified jobs in the region and country. Retaining knowledge, highly specialized knowledge and expertise must be retained to create preconditions for future new builds. Also, involvement of local industry, capability and capacity of local industry to support construction and operation of future new builds is important. And then a transition to green energy. LTO of existing power plants will allow additional time for developments towards sustainable low carbon energy. A long-term operation of existing reactors from 30 or 40 years of operation based on original design lifetime to 60 years is already a relatively standard process in most of the countries operating nuclear power plants. And it is based on two basic approaches. One can be described as a PSR-based approach, which is used in countries with unlimited licenses, with a periodic safety review for LTO typically more rigorous, with a greater focus on aging aspects, covering the whole intended period of long-term operation. And the second approach is a license renewal-based approach, which is used in countries with a limited license, which is typically limited to 30 or 40 years, and usually allows additional 20 years of license extension. These are two typical approaches to justify or demonstrate preparedness for long-term operation, but in most of the countries we see combination of these two approaches. As of this year, more than 30% of all units are already in operation for more than 40 years. So we can say that they are in long-term operation already. If we do projection to 2050, we could see that more than 50% of current power plants will have been operating for at least 60 years, if they will operate beyond 60 years. To reach net zero carbon emissions goal by 2050 and ensure energy independency, LTO beyond 60 years appears from this reason to be an essential contributor. How it looks currently in individual countries operating nuclear power plants. Several countries already initiated standard process of licensing or operational permit extension beyond 60 years. We can mention USA, where several, currently more than 10 PWR and BWR units obtained license for up to 80 years. This is a license extension from 60 to 80 years. Or in Canada, where several CANDU units were refurbished, which will allow operation up to 76 years of operation. And also in Finland, where we have an Olkiluoto power plant with 2 BWR units, and both units already obtained a license extension from 60 to 80 years. And also Loviisa, VVR 440 units in Finland, which also obtained license both until 2050, which means 73 years for Unit 1 and 70 years of operation for Unit 2. In many other countries or nuclear power plants, activities to extend the lifetime beyond 60 years were initiated with the feasibility studies and in some also with the technical assessment. We can mention a couple of examples. For example, Borssele PWR unit in the Netherlands, lifetime extension from 60 to 8 years is in a phase of technical assessment. Similarly, in EDF France, fleet of PWR 900 megawatt units, the oldest units which are currently in operation in France, are in the same phase of technical assessment. Also, PACSH VVR 440 units are currently in a phase of technical assessment to extend the lifetime from 50 to 70 years. And also 2 PWR units at the Ringhouse power plant in Sweden are in a phase of technical assessment. Then we have a couple of power plants which are in a phase of feasibility study. We can mention Forsmark PWR units or Dukovany VVR 440 units or Krško PWR unit. All these power plants are currently in phase of feasibility study to evaluate operation up to 8 years. So that was briefly about current perspectives of LTO beyond 60 years. Now I will say a few words about IEA safety standards and other publications to support aging management and long-term operation beyond 60 years. So it's important to say that IEA safety standards represent consensus of the IEA member states and fundamental guidance for demonstration of preparedness for LTO. IEA safety standards are applicable to the whole period of power plant operation, which includes also long-term operation beyond 60 years. IEA safety standards are regularly updated, approximately once in 10 years, and include the latest experience of member states and reflect the recommended approach to aging management and preparation for safe LTO. IEA publications which are below the level of IEA safety standards, such as safety reports, technical documents, may distinguish between LTO up to 60 years and beyond 60 years. For example, in IGAL safety report, aging management programs or TLAs can be different for LTO up to 60 years and LTO beyond 60 years. But on the level of IEA safety standards, they cover, all IEA documents cover also LTO beyond 60 years. I said that IEA safety standards and other documents are periodically updated. So now you can see that all the key documents or safety standards related to aging management and a long-term operation are currently in the various phases of revision. For example, SSR 2/2 and SSG 25 are in a, let's say, last phase of revision just before finalization. And on contrary, SSG 48 revision was initiated last month. IGAL safety report is basically in a constant update with a new revision of all related documentation published biannually. And regarding safety reports, new safety report on safety aspects of aging in design, construction, and commissioning is also ready and is in a preparation for publication. Regarding the latest development of IEA safety standards, I would only mention that in SSR 2/2, which are requirements on commissioning and operation, we have a revised requirement 26 on aging management program and the requirement 27 program for long-term operation. I would mention here that in the requirement on program for long-term operation, in its second part, we have a updated terminology, which is already 7 years used in SSG 48. It means, for example, time-limited aging analysis, aging management programs, review of aging management, etc. All these generally used terms are now introduced in requirements on commissioning and operation in a requirement for long-term operation. Regarding safety guide on aging management and LTO, as I said, the revision was initiated last month by technical meeting on SSG 48, and target date of publication of a new version of this safety guide is end of 2029. So what are the basic inputs for the review of SSG 48? It will be experience from subsequent LTO preparations, including OECD and EA LTO beyond 60 years report, LTO justification approaches, which are currently described in Safety Report 121, aging management in early phase of power plant life cycle, which will be described in the new safety report, which I mentioned on previous slide. Then human resources, knowledge management, and competence management aspects in LTO program, which will be described in a new tech doc, and are reviewed usually during the SALTO missions. Then a concept of a plant level aging management program as described in IGAL safety report, aging management effectiveness assessment also described in IGAL safety report, and aging management of active components currently also described in IGAL program. And then also extend the recommendation on aging management review, which is already described in IGAL safety report. So these are examples of some, let's say, key modifications or enhancements which will be performed in SSG 48 based on low-level documents, safety reports and tech docs of IEA, but definitely there will be many other changes to improve quality of SSG 48. Last month, we also discussed the new structure of SSG 48. So in a technical meeting, this structure of the SSG 48 was agreed. And what I would say that important change, in my opinion, is that we want to say that the aging management should be in place since early phases of power plant lifetime, which means design, commissioning, and early years of operation. And as such, it should be seen as one of the programs which needs to be in power plant since the very beginning, and it need to collaborate or interact with other plant programs and processes. And preparedness for LTO is basically using existing programs like aging management programs, technological obsolescence programs, and demonstration of preparedness for LTO. So this is regarding latest developments in IEA safety standards. And now I will talk about OECD LTO Beyond 60 Years project. So this project was introduced to map the status of knowledge regarding LTO of power plants beyond 60 years and identify potential gaps in knowledge and technology. And also to identify possible solutions to disposition the areas that they need, which need enhancement. Project was started by NRG in October 2022 and was concluded in June this year. We created a team of about 85 experts from 14 countries and 3 international organizations. And project outcome is a status report on LTO beyond 60 years, which was approved in June this year and is already available. Official publication is expected in December this year. Here you can see a list of contributing organizations. So in our project team, we had research institutes, nuclear regulators, utilities, other organizations, including international organizations. This is the structure of the report, where you see 5, let's say, descriptive sections and section 6 with conclusions. The main focus was on technical challenges important for LTO beyond 60 years and safety requirements important for LTO beyond 60 years. And based on that, we developed conclusions of 2 types of conclusions, identified areas for enhancement and areas properly addressed. In a section 4, as you can see here, for a reactor pressure vessel, every subsection has the same structure, description of the component or system, then physical aging, inspection and diagnostic methods, repair, refurbishment and replacement solutions, and potential gaps for LTO beyond 60 years. So results are areas properly addressed, which provide technical audience with information and advice on what is available, documented, and can be used as a knowledge basis for assessment, justification, and preparation for a safe LTO beyond 60 years. We have here 16 areas properly addressed, but it does not mean that this covers all the topics or areas which are properly addressed. Then the major focus was on identified areas for enhancement, which means that these areas need attention to ensure safe LTO beyond 60 years. It's important to say that no technical issue of a generic nature linked to the effects of aging has been identified as a critical and liable to involve systematic shutdown of power plants after 60 years of operation. And most of the areas for enhancement lead to research activities aiming to improving the knowledge of aging phenomena and the performance of engineering methodologies for safe LTO beyond 60 years. We identified 68 areas for enhancement. Here you can see the overview of areas for enhancement based on the sections or subsections of the report, which are they based on. And as you can see that the majority of the areas for enhancement are for reactor pressure vessel, internals, safety class 1 piping, concrete containment, civil structures, electrical cable systems. I put here on one slide examples of general or more general areas for enhancement, like supply chain, human resources, obsolescence management, to show you that some areas for enhancement are more of a general nature. And here on this slide, you see examples of more technical areas for enhancement, First two are for RPV, then we have for RPV internals, etc. As I already said, the project was concluded basically in June this year. So now we are in a phase of dissemination of the information, and also in a phase where we want to discuss how to disposition areas for enhancement. So for this purpose, we had in early November a workshop in Paris, and the purpose of this workshop was to discuss and clarify areas for enhancement, discuss and agree upon suitable solutions, as well as a possible collaboration on dispositioning of individual areas for enhancement. We had 55 participants from 11 countries, and we discussed approximately 50 more technical, let's say, areas of enhancement, and around 30 of them in a detail. And we will prepare meeting minutes and we will share them with interested parties very soon. So to conclude on my presentation, LTO beyond 60 years is essential to reach net zero carbon emissions goal by 2050, retain knowledge, capability, and capacity of industry to support construction and operation of future power plants. The IEA safety standards and other publications support LTO, including LTO beyond 60 years. And nuclear industry, regulators, and research organizations are invited to discuss OECD NEA LTO beyond 60. That's the last one, and thank you for your attention.
So thank you, Robert, for your nice presentation. Give us beautiful overview and information that it's not something which is being discussed, but it's being implemented. And now I will give the floor, the virtual floor, to Andreas to give us a presentation about how they did it or how they are doing that at the Borssele nuclear power plant.
Thank you, Andre. Do you see my screen?
Yes, yes.
Oh, perfect. Okay. Good day, everyone. Colleagues, it's an honor to present our story from the Borssele nuclear power plant. Actually, I never noticed that the Netherlands has become part of Belgium, but who knows? I like Belgium, but we are from the Netherlands. And I'll share the Netherlands story. Okay, so in these 20 minutes, I'll give you an overview of our preparation for subsequent LTO. We call it LTO 2, by the way. So that's our the name we use for subsequent LTO. I'll first give you a picture of nuclear in the Netherlands, then the Borssele nuclear power plant, our LTO approach, and finally some results and lessons learned preliminary. We are a small country, but actually quite interesting from a nuclear perspective, because we have 2 research or isotope reactors and we have 1 in construction at the better side, the Pallas reactor. So there's actually being built a new nuclear power plant in the Netherlands. We also have what I call a pre-SMR. It was a very interesting reactor in the east of the country in Dodewaard. It was a natural circulation boiling water reactor with a very low power, and it closed down in the 90s, but it's now in permanent shutdown. We have an uranium enrichment facility. We have some accelerators, a waste disposal facility near Borssele, where the power plant is, which I'm going to be talking about. And of course, the Dutch government has ambitious plans for 2 large new builds in the near future, and after that, 2 additional support for SMR, such as the Allseas initiative you maybe heard about, and LTO 2, of course, for Borssele nuclear power plant. Here you see a picture of our beautiful plant with the white dome, and here you see in the yellow is the waste disposal facility, and there's some room actually to facilitate new builds. Borssele nuclear power plant, it's one of the oldest in Europe. We were constructed in 1969, built by Siemens KWU. We were sort of pre-convoy design. So not all the benefits of the later convoy designs, but we have some benefits in the design, which is a very robust design. So the materials are of high quality. It was also built as a full load following plant back then, but it was never used, that capability. So we never operated as a load following, but as a base load plant. It was designed for a design life of 40 years. So that expired in 2013. But before that, there was a covenant agreed to prolong the lifetime. And that project ran. And in 2013, we got the license for LTO, which, we are now in. So we're actually in LTO. We're in 52 years of operation already. We did a secondary site power upgrade, but never a primary site. And we did a PSR every 10 years with a lot of safety upgrades, which brings us in a good position now to pursue a subsequent LTO. There's one special thing about the situation in the Netherlands. The result of that covenant that was agreed is that there is now in the law, in the Nuclear Energy Act, there's now a clause that prohibits us from pursuing LTO2. It literally says Borssele cannot operate beyond 2033, and you can also not apply for a license. So that's a very special situation. So then the question is, why are we investigating subsequent LTO? That is because the government I just mentioned has the ambition to pursue subsequent LTO and asked us to perform the necessary investigations. So even though the law prohibits it, we are investigating it as a request of the government. So it's nice that these ambitions are there, but it's not so trivial. And these are the 5 elements we have to overcome. And the first of those elements is the change to the Nuclear Energy Act. So that clause that prohibits us from pursuing LTO2 needs to be modified. I think 2 weeks ago, the minister sent this modification to Parliament. So we don't know yet when the vote will be, but it will be soon. So then the first element hopefully will be overcome. The second is a new covenant. Also in the Netherlands, the government is investigating taking over the majority share of the Borssele nuclear power plant. So they're stepping in as well. And that will give them a final say on the lifetime extension. The feasibility studies, that is what we are working on. So I am responsible for the technical feasibility studies. And I'll tell you a little bit more about that in the next slides. If we have the good results from those studies, we can apply for a license for LTO. And then after that, the shareholders, they can take a final investment decision. The timeline for all this might be interesting for you is we will apply for a license in 2027 and the final investment decision is now scheduled for 2029. So that is our timeline. So I cannot yet provide you with definite results, but only some intermediate results and lessons learned. And I will probably be back in a few years with some good news. Yeah, because it's an interesting topic and a lot of interest is there from around the world. I wanted to share with you some of the topics that you will likely meet or you likely have to consider when pursuing LTO or LTO2. At the heart of this assessment for LTO is physical aging, of course. We have to demonstrate that we manage the physical aging. Like Robert just explained, there are, of course, challenges. You see a picture of one of the challenges Borssele used to face with the degradation of the wires. But we are now working hard on, again, demonstrating that we manage the physical aging for the plant for the next LTO2. Another topic that you will encounter is technological obsolescence. So that's becoming obsolete of technologies due to suppliers not being there anymore, maintenance not being able to perform the necessary maintenance, spare parts availability. And that is actually quite a challenge. And I saw it already in the sheets of Robert. But for us, especially INC, this is one of the topics that gives us the most food for thought. Because it's not so trivial to exchange your INC. And also, you know, that modern INC becomes obsolete much faster. So it's not such a trivial decision. And we are preparing a very robust investigation to make that decision. Also, state of art, that's something in the Netherlands you have to consider. So we perform an additional periodic safety review to again compare the plant to state of art and see where we can improve safety. And that is also in the requirements by IAEA, because you have a longer timeline to consider. It also becomes more favorable in most cases to implement safety improvements. Another topic we are preparing for is preparing the organization and the necessary competence to implement the LTO2 program. The fuel cycle we have to consider, of course, from front end to back end, and the environment. That's also a very interesting but difficult topic, especially in the Netherlands, for two reasons. First, the environmental impact assessment we have to prepare. So we have to identify all the impacts of the LTO2 program. But also, and sometimes that's quite difficult, for example, the nitrogen debate. But also because the environment changes. So climate change brings itself different challenges. And of course, a result of all these studies is having a clear investment portfolio and business case that will be supported by the shareholders. Then I'll show you the approach we developed for performing all these assessments. We have different work streams, and I'll start from the top. We wrote a project plan. I think we're now in version 17 already, so it's not so you cannot think upfront exactly what you're going to do, but it's a development. But I think we now have a clear grasp of what we need to do. And what you see here in green is all the topics we discuss with the regulator. So it's a large part of the LTO2 preparations, and in gray, it's the part that we prepare for ourselves and for the final investment decision. So we develop a portfolio by mapping all the installation risks and opportunity and develop the best solutions, including necessary spares, the fuel cycle, and the necessary organization. And we do that by a lot of international exchange and involving parties like our original equipment manufacturer, Framatome. But also exchanging with the Swiss colleagues, with the Belgian colleagues, and I think I saw some of the colleagues in the call today. The second two assessments are we do a safety assessment, but we broke it in two parts. First, the safety demonstration is really demonstrating that we can manage physical and non-physical aging in an effective way, and there we used a lot of the topics Robert already pointed out. And what helped us there a lot was the pre-Salto mission we had last year in November. So I can highly recommend that to get a clear picture of what you need to do. And we also perform a periodic safety review to identify any reasonably practicable safety improvements. And lastly, we provide an environmental impact assessment. So we wrote basis documents for all these assessments. We're now executing them, and that would lead finally to a final safety analysis report, an environmental impact assessment report, implementation plans, and a license application. And you can see here on the right some of the reference we use. So for example, for the PSR, we will make use of the reference of the OECD NEA Beyond 60 report Robert just mentioned. Well, some results. As mentioned before, the reactor pressure vessel is one of the most important topics to consider in physical aging. And actually, we are in a good position in Borssele because the The manufacturing was of very high quality. We had a low leakage score for most of the life of the plant, and we performed already surveillance programs. We're now performing the 5th surveillance program. But we were in a situation that for the first LTO, the fluence level reached was already 76 years. And we have enough samples to reconstitute and make a set that covers 80 years. So we have for the belt line materials, we have already the results. And they show that we have ample safety margin for 80 years. So we have, we basically know that. We only have to complete the investigations. State of art now is that you also investigate the extended belt line region. That is what we're doing. So we made a new irradiation set, which is now in the reactor. So you see here on the right a nice picture of our reactor and the irradiation set being inserted. And we will take it out next outage and do the testing and then complete the safety assessment. There's also a paper being written and submitted to the ASTM. So you will see that and can look in more detail to the results, because it might be interesting for some of the colleagues, especially this reconstitution. Another piece of good construction were the steam generators. We already know, because of the good materials and all the aging mechanisms being known and a good chemistry, that we can operate them for 80 years. So we have plugged about 80 or 90 of the more than 4,000 tubes. So it's less than 2% after 52 years of operation. So we can manage that as long as we're careful, of course. So some preliminary results of the investment studies. I'm not going to share numbers, of course, but you can see here percentages. And as I talked about before, electrical and INC make up almost half of the total amount. So that is a topic we are very much looking more into. So especially INC from an obsolescence perspective is challenging. Mechanical reheaters and radioactive waste treatment, electrical, a lot of motors that are end of life that we have to consider. Transformers, the generator, cables, civil, cooling water intake structure repairs are interesting. And a lot of safety improvements to consider. And of course, as always, there's room for more study. And then I want to end with some lessons to share, and then we can go into the questions. We thought about this. This is a combination of lessons we took from LTO 1, preparation and execution, and LTO 2. So some generic points. The first is essential. It's clarity about regulatory requirements and a good liaison with the authorities. And that is crucial to decrease risk of delays. So we try to be which is not that easy, because in the Netherlands there's no clear regulatory guidance for preparing for LTO 2. So we developed that based on IAEA requirements and guidance and agreed that with our regulator. The second is it's a big project with a lot of topics. So it requires a dedicated structure and management to be able to manage all that. And what helped us a lot in that is risk management. So we have a risk register. We update that every month because new topics keep coming up. And as long as you're quick to address them, you can manage these risks. But you need to have a clear view on them. That's one of the pre-Salto outcomes as well. It was actually an advice by our Hungarian colleagues, which came into the Salto mission. Also, international cooperation. Well, we're here today. And it helped us a lot in gaining insight and finding solutions for questions we had. And as mentioned before, the pre-Salto mission, that was really, for us, provided a lot of clarity. So I would advise to invite the team if you are preparing for LTO. And one thing we learned from LTO 1 is that the clear justification of all the individual investments is very essential, because that will always be challenged. And if you have the justification available, it makes life much easier. Then specifically for LTO2, so we concluded LTO1. We took the aging management review and we put it into our management system and kept the aging management review alive. And that brings us in a good position. But what we also noticed is the world keeps changing. The IEA regulations keep changing. But we need to keep an eye on that, because when we concluded the pre-Salto mission, we also concluded that we still have a lot of work to do to catch up to those international requirements. So the advice is to keep the aging management alive. As mentioned, obsolescence issues are more urgent because these technologies are now coming really obsolete after 52 years of operation. And it's worth a lot of effort to clearly think about what you're going to do, because it's not so trivial to change INC. What we also see is the regulatory framework. It keeps on growing. It's a fact of life. It's not always easy to deal with. For example, environment or public participation requirements. So involve people that know what to do with this. And we have a team in Borssele that have a clear grasp on the regulations, but also have a technical background. So we're lucky with that. But still, it's a big challenge to keep track of all these regulations and how they combine. And sometimes they don't combine. They exclude each other. And what we see, and you also see probably, is that people that were present at the construction have retired, which poses sometimes more challenges in finding the right information. So if you have those people, we are lucky to have a few of those people. Keep them involved in the project, and also keep the databases and design information well structured, and make it able to find the necessary information. So these are some of the lessons we can share at this stage in the project. I'm happy to share more once we are in a later stage. Thank you.
Okay, thank you, Andreas, for a nice presentation. Now we have time for questions, so feel free to put them in our chat. We just received one, which will be probably to you, Andreas. You said you just got the results from the belt time sampling campaign. Can you share what's the current effective value, etc.? You see it, the question, if I hope. Or safety margin that you have, as you said, that it's still large. Which transient was used to estimate the margin?
Sorry, I can't see the question.
You don't? Okay. So I will read it again, and hopefully it will be enough. So you said that you just got results from the Beltline sampling campaign. Can you share what is the current effective RT underscore NDT value or safety margin that you have? Or as you said that it is still large, which transient was used to estimate this margin?
That is a very detailed question, and if I can share it, but I don't know it by heart, so I have to look that up.
So
I only know that the embrittlement response from going from 76 to 80 years is almost negligible. So that makes no difference for the margin we already have. That is the only answer I can give now. But
so Mr. Ed Gargas, who posed the question, you can probably email Andreas with the question, and he will answer what in the scale as he's allowed to answer. So
yes,
that will be the result for that. Then we have another question from another listener, and it's that Angra nuclear power plant. How are you managing the fact that the KTA standards are being discontinued? That's probably on you, Andreas, again.
Yes, that's a very interesting question. That's something we are considering as part of this periodic safety review. And we haven't come to a final conclusion on that yet, because again, it's not so trivial to go to a new code system. So we have to consider what what is wise. And I cannot give a definite answer at this moment, but it will be an outcome of the periodic safety review.
Okay. Then we have another one.
It's good to share this with the colleagues that use the KTA standards. So I'm happy. If we could come into contact to share our views, and also maybe share some thoughts and how to proceed with this. Yeah.
Okay. Next question that we have there is that whether the EPZ make any interesting findings at other RWU users when developing their LTO-2 strategy. So Andreas, that's probably again on you, whether your findings helped others in their development.
Technical or organizational, I hope at least we have some from the exchanges we made. We shared some of our approaches, which will help. But I don't know if it's about technical findings or organizational. Or what is it about?
Any interesting findings? So we don't know what was the question placed that way. Technical. So if you have some technical findings in that area that you share with them.
Yeah, I think the most interesting technical is for us this reconstitution of the samples we already have from the previous irradiation campaign of the reactor pressure vessel, which we will share by this ASTM paper.
Okay,
so we didn't find any so far. So the investigation is still ongoing, but we didn't find any specifically new topics that were not already known within the industry. It's like Robert already pointed out. There's no specific or general technical issues identified of major concern as compared to LTO from 40 to 60 or from 60 to 80.
Okay. Then we have another questions, and what kind of analysis you have done on competence and organization?
Yeah, so our HR department, they are developing different scenarios. So these scenarios are constantly updated, providing the new information we get from the researches we do. And that is quite an interesting way of approaching it, I think. And you cannot, of course, look 100 years in the future, but you can identify different scenarios and constantly update them. So that is the way we approach it. But it might be one of these areas of interest also for LTO beyond 60. Robert pointed out in the report areas for enhancement. And I think there was we published actually the Salto report, so you can have a look there. It's mentioned there.
Okay. Yeah. We have another questions here. Is it possible to have LTO up to 100 years? That's maybe a question on you both, what's maybe Robert thinking about it, or you, Andreas?
I think it's an interesting question, but I guess Robert has a broader picture on that.
I think first more practical question is above, which is how maybe cater aging management of spare parts in perspective of LTO, and how can AMR tables of IGAL may be helpful in this regard. So I think I will first answer this one, because this is for me. So aging management of spare parts in perspective of LTO, but not only in perspective of LTO, should be managed both on the side of physical aging and technological obsolescence or non-physical aging. And this is both described in a SSG 48 partially on general level. And then in IGAL, we have a program which is not on the same level as a aging management program for spare parts, aging management of spare parts. And why it is not on the same level of detail as other aging management programs? Because it covers all spare parts and all their relevant aging effects. In the future, if it's needed, there is of course possibility to develop specific aging management programs for specific spare parts if there are any specific degradation mechanisms and aging effects which does not appear during the normal operation. But so far there is a program on aging management of spare parts which is a bit more general. And also technological obsolescence of spare parts is one of the key topics in a technological obsolescence program, which is also part of the IGAL. And the second part of the question, how can AMR tables of IGAL may be helpful in this regard? So far, we do not have a technological obsolescence program and aging management of spare parts program in IGAL AMR tables because they are on a more general level and they do not specify aging effect for each component or structure which is covered by this program. So that's why they cannot be in aging management review tables, because it's basic condition in aging management review table to identify combination of component and its aging effect and degradation mechanism. But in future, if we go to more details for some spare parts, then we can add also the aging management of some spare parts in aging management review tables. Currently, it is not possible. And regarding this LTO up to 100 years, of course, it is possible. It depends on the status of components and also on regulations and also acceptance by public. And yeah, but right now it looks that technically it would be possible.
Okay, we have probably last question that's dedicated for Andreas. Thanks for the next presentation. Based on your LTO2 review, do you point to any topics or areas that LTO research should be focused in the near future to help your LTO2?
From our experience, at least, it would be very helpful to get more guidance, I would say, and also a more hands-on experience with dealing with technological obsolescence. And that's not necessary. Yeah, maybe it could be a specific research area because it's just very difficult. And I think for every organization, it's very difficult to deal with that. And it has to do with regulations, processes, qualification, suppliers. So it's for the nuclear industry. I think it will be very beneficial if we have more clarity on that.
Okay, so that's probably all from the questions. So we can conclude. So thank you again, Andreas and Robert, for your nice presentation. We had a lot of people online watching us, so I see it was topic probably very interesting for the community, and there is a big chance that there will be some follow-up webinars dedicated to LTO. So don't forget to follow channels, and maybe next year there will be another seminar dedicated to development in LTO and topics connected to that. So thank you again, and thank you all you that you joined us today, and hopefully you learned something new today.
Thank you very much.
Thank
It was a
you.
pleasure.
Thank you.